Earth formed around 4.54 billion years ago by the accretion from the solar nebula. Volcanic outgassing probably created the primordial atmosphere and then the ocean. But the atmosphere contained almost no oxygen, and so would have been toxic to most modern life, including humans. Much of the Earth was molten because of frequent collisions with other bodies, which led to extreme volcanism. A giant impact collision with a planet-sized body is thought to have been responsible for the forming of the Moon. Over time, the Earth cooled, causing the formation of a solid crust and allowing liquid water to exist on the surface. The geological timescale clock depicts the larger spans of time from the beginning of the Earth as well as a chronology of some definitive events of Earth's history. The Hadean Eon represents time before the reliable fossil record of life beginning on Earth. It began with the formation of the planet and ended at 4 billion years ago, as defined by international convention. The Archean and Proterozoic eons followed. They produced the abiogenesis of life on Earth and then the evolution of life. The succeeding eon is the Phanerozoic, which is represented by its three-component eras: the Paleozoic, the Mesozoic, which spanned the rise, reign, and climatic extinction of the huge dinosaurs, and the Cenozoic, which represented the subsequent development of dominant mammals on Earth. Hominins, the earliest direct ancestor of the human clade, rose sometime during the latter part of the Miocene epoch. The precise time marking of the first hominins is broadly debated over a current range of 13 to 4 million years ago. The succeeding Quaternary period is the time of recognizable humans, the genus Homo, but that period's 2 million year plus term of the recent time is too small to be visible at the scale of the GTS graphic. The earliest undisputed evidence of life on Earth dates at least from 3.5 billion years ago during the Earchean era, after a geological crust started to solidify following the earlier molten Hadean Eon. There are microbial mat fossils such as stromatolites found in 3.48 billion year old sandstone discovered in Western Australia. Other early physical evidence of a biogenic substance is graphite in 3.7 billion year old metasedimentary rocks discovered in southwestern Greenland, as well as remains of biotic life found in 4.1 billion year old rocks in Western Australia. According to one of the researchers, if life arose relatively quickly on Earth, then it would be common in the universe. Living forms derived from photosynthesis appeared between 3.2 and 2.4 billion years ago and began enriching the atmosphere with oxygen. Life remained mostly small and microscopic until about 580 million years ago, when complex multicellular life arose, developed over time, and culminated in the Cambrian explosion about 441 million years ago. This event drove a rapid diversification of life forms on Earth that produced most of the major phenomena today, and it marked the end of the Proterozoic Eon and the beginning of the Cambrian period of the Paleozoic era. More than 99% of all species, amounting to over 5 billion species that ever lived on Earth, are estimated to be extinct, estimated on the number of Earth's current species ranging from 10 million to 14 million, of which about 1.2 million have been documented and over 86% have not yet been described. More recently, in May 2016, scientists reported that 1 trillion species are estimated to be on Earth currently, with only 1 of 1,000 of a 1% described. Geological change has been a constant of Earth's crust since the time of its formation, and the biological change since the first appearance of life. Species continues to evolve, taking on new forms, splitting into daughter species, or going extinct in the process of adapting or dying in response to ever-changing physical environments. The process of plate tectonics continues to play a dominant role in the shaping of Earth's oceans and continents in the living species they harbor. Changes in the biosphere, now dominated by human activity, continue in turn to produce significant effects on the atmosphere and other systems of the Earth's surface, such as the integrity of the ozone layer, the proliferation of greenhouse gases, the conditions of productive soils, and clean
Created using Powtoon.